Hey, welcome. Today, we are uncorking the science behind a chemical that's pretty much hiding in plain sight. Seriously, it's in our fuel tanks, our medicine cabinets, and yep, even our weekend cocktails. So stick around as we dive into the fascinating world of ethanol.
So let me just start with a quick question for you. What in the world could possibly be the chemical link between a fuel additive, a bottle of cough syrup, and a glass of wine? I mean, they seem totally unrelated, right? Well, the answer is a surprisingly simple but incredibly powerful molecule.
So in this explainer, we're going to take a four-part journey. First, we'll meet the molecule itself. Then, we'll see how it reacts. After that, we'll explore its role in our world. And finally, we'll cover some really crucial safety warnings. Let's get right into it.
All right, first things first. Let's get properly introduced to this molecule. What exactly is ethanol anyway? Okay, so at its core, ethanol is a simple alcohol. You can see its chemical formula right here, C2H5OH. That's 2 carbon atoms, 6 hydrogens, and 1 oxygen. It also belongs to this family of compounds called a homologous series. You can kind of think of it like a set of Lego blocks, where each block is just a little bigger than the last, but they all share the same basic design and chemical properties.
Now, these basic properties are really the secret to its versatility. Because it's such a fantastic solvent, it's perfect for dissolving things in medicines, like cough syrup. Its ability to mix completely with water in any amount makes it incredibly useful in all sorts of applications. And of course, this is the exact molecule that gives all alcoholic beverages their kick.
Okay, so we know what it is. Now let's see what it does. This is where the chemistry gets really exciting, and we're going to look at 2 of its most important reactions.
First up, what do you think happens when you mix ethanol with a super reactive metal like sodium?
Well, it's a pretty dramatic process. You drop in a small piece of sodium and boom, it immediately starts to fizz. And that fizzing, that's a huge clue for any chemist. It tells you a gas is being created. In this case, it's hydrogen gas, bubbling right out of the solution, and it leaves behind a totally new compound called sodium ethoxide.
And here's the full chemical story of what we just saw. 2 sodium atoms react with 2 ethanol molecules. They basically kick out a hydrogen atom from each one. And those 2 hydrogens pair up to form that hydrogen gas. This leaves the sodium to take its place, creating that sodium ethoxide.
All right, now for our second key reaction, dehydration. And yeah, it's exactly what it sounds like. We're literally going to remove a water molecule.
Now, to make this happen, you need a little help from a catalyst. In this case, it's hot, concentrated sulfuric acid, and it acts as a powerful dehydrating agent. Its one and only job here is to grab a water molecule right out of the ethanol.
So here's the transformation. The ethanol molecule loses an H and an OH group, which just snap together to form water. But now, the carbon atoms they left behind are kind of unstable. To fix this, they form a new, stronger double bond between themselves. And just like that, they've transformed the molecule into a completely different compound, ethene.
So we've seen the chemistry, but now let's connect it to our actual lives. How does this one simple molecule play such a massive role in our world?
Its versatility is just incredible. We've already seen it as a solvent in medicine and as the key ingredient in beverages. But it's also added to gasoline to help cars run cleaner, and it's a cornerstone solvent used in manufacturing all over the world. It's everywhere.
So where does all this industrial ethanol even come from? Well, a huge source is sugarcane. These plants are incredibly efficient at converting sunlight into chemical energy, and their juice can be fermented to produce ethanol. It's truly a direct link from a sunbeam right into the fuel in your tank.
Okay, now for our final and maybe most important section. For all its amazing uses, ethanol and its chemical relatives have to be handled with extreme care.
This is a critical warning, so listen up. While dilute ethanol is what's in alcoholic drinks, pure ethanol, also called absolute alcohol, is highly dangerous. Even a small amount can be fatal. It acts as a powerful depressant on the central nervous system, and long-term consumption can lead to absolutely devastating health problems.
And it is vital to distinguish ethanol from its close cousin, methanol. They sound similar, but believe me, their effects are worlds apart. Methanol is extremely toxic. Inside the body, it gets metabolized into substances that are incredibly destructive, especially to the optic nerve. And that's why even a tiny amount can cause permanent blindness or even death.
Because ethanol is so useful in industry, there has to be a way to stop people from drinking it. The solution is something called denatured alcohol.
Industrial ethanol is deliberately poisoned, often with methanol, and it's colored with a blue dye to make it instantly identifiable and, most importantly, undrinkable.
So, there you have it. Ethanol, a simple molecule that can power a car, treat an illness, or end a life. It's a perfect example of chemistry's powerful dual nature. And this kind of leaves us with a final thought. What other simple chemicals in our world are just as complex, just as useful, and just as dangerous?